All right, hello, grade nines. I hope you're well. I hope you're well. Hope you're well. Hope you're well. Hope you're well. All right, so we are actually just having grade nines here. Grade nines. Just guys, this is just a session for the grade nines GEC. All right, and I just want to say to the grade 9 GEC learners that on my YouTube page, right, on my YouTube page, I just want to show you something here to those who may not know. But on my YouTube page, I've got a YouTube channel here. It's called MATHSISAGAME. You should be able to see there on my page the first video there, grade 9 GEC paper 1, question 1 to question 9 multiple choice. This is the grade 9 2022 GEC that I've done so far for the grade 9s. So grade 9s, you guys can actually check out the question 1 to 9 that I've done. Because when you guys are writing GEC as grade 9 learners, it's very important that you understand that much of the GEC paper is multiple choice. And since it's multiple choice, it means that you need to have a way of being able to answer the questions. So I've done question 1 and 9 already. If you guys want to watch that, you can go to my YouTube channel. It's called MATHSISAGAME. The link is in my bio. And then you can watch the full video, which is 1 hour 36 minutes, where I go over the questions that were done in GEC grade 9 paper 1 in the year 2022. I'm going to be continuing on today from question 10 and onwards and see where we end. So I'm going to switch back then to the questions that are before us. All right. Yeah. I hope you guys are with me in that. So there we have question 10 there at the top for grade 9s. So question 10, guys, at the top, grade 9 says 25 to the power 0. Okay, you can see that 25 to the power 0, right? I hope you can. 25 to the power 0 in brackets minus 5 in brackets to the power 0 plus 5 to the power 4 times 5 to the power 2 divided by 5 to the power 3 all squared. Okay, so hopefully we can see all of that, okay, on our paper. All right, and so we need to, as it says, what is the answer in simplest form? Question 10, we are there, and they have given us options there. A is 1, B is 5, C is 21, and then D is 45. So I don't know anyone who's here. Number 10, we are at question 10. What is the answer in simplest form? We have 25 to the power 0 minus 5 to the power 0 plus 5 to the power 4 times 5 to the power 2 divided by 5 to the power 3 all raised to the power 2. So there we are being asked, what is the answer in simplest form? Is it A, 1, B, 5, C, 21, or D, 45? So what's important then here is that we need to actually go ahead and answer this question first. So let's go and actually write it down so that we can then attempt to answer the question. So 25 to the power 0 minus 5 to the power 0 plus 5 to the power 4 times 5 to the power 2 divided by 5 to the power 3 raised to the power 2. Guys, as a grade 9 learner, you should be able to see that this here we have many operations, okay? And we have a minus sign, we've got a plus sign, we've got a multiplication sign, we've got a division sign. So what does that then say to you? It says we need to apply BEDMAS, okay? Brackets gets first priority, exponents in that order, division, multiplication, addition, and then subtraction in that order. So when we look at this, guys, we can obviously attend to the brackets, okay? First and foremost, as per the order in BEDMAS, brackets. So what's 25 to the power 0? So if we know our laws of exponents, anything raised to the power 0, we know is what? It's equal to 1. So 25 to the power 0 is 1, minus 5 to the power 0 is also 1, okay? Yeah, plus, then we have 5 to the power 4 times 5 to the power 2, divided by 5 to the power 3 raised to the power 2. Now, these are separate terms. This is 1 minus 1 plus. Now, all of this here, we have multiplication and division. Okay, so since we have multiplication and division, let us apply the laws of exponents here. Okay, guys, with division and multiplication, we can attend to the division, then the multiplication, or vice versa. Okay, BEDMAS, or we can say BEMDAS. So whether you start with division or multiplication is not of importance. You can start with division and then follow with multiplication, or you can start with multiplication then follow with division. But for now, we're still attending to the brackets. So 25 to the power 0, we've attended to. 5 to the power 0, we've attended to. For now, let's write 5 to the power 4 times 5 to the power 2 divided by. Now here, there's another bracket. There's an exponent. So then we have to attend to that. Okay, brackets, exponents. That's why brackets, exponents, we attend. Brackets, exponents, we attend. Brackets, exponent. So I've left this for now, but I'm going to attend to this. 5 to the power. Remember, the law of exponent says when a base is raised to an exponent and outside that bracket there's another exponent, what do we do to the exponents? 5 to the power 3, this becomes 3 times 2. So 3 times 2 is 6. Okay, so we've attended to the brackets together with the exponents. Now the next thing we need to look at is division and multiplication. So for now, guys, I'm just gonna say 1 minus 1, leave it like that, plus, now we have multiplication and division. We can attend to these at the same time. So the multiplication, if we have bases that are the same, guys, 5 to the power 4 times 5 to the power 2, what does the law of exponents say with multiplication of bases that are the same? So I hope you understand and remember that if you are multiplying same bases, let's say a to the power m times a to the power n, we know that we keep the base and then we add the exponents. So if we are multiplying same bases, we keep the base, we add the exponents. If we are dividing bases that are the same, then we keep the base, we subtract the exponent. Very important, this thing. So if you look at this, guys, 5 to the power 4 times 5 to the power 2, that's like saying 5 to the power 4 plus 2, but then it says divided by 5 to the power 6, so we say minus 6. Because what do you notice? These bases are all the same. 5 to the power 4 times 5 to the power 2 gives me 5 to the power 4 plus 2 as an exponent. But then since we are dividing the very same base, it then means we can subtract the exponent 6. Let's proceed. 1 minus 1 plus, now 5 to the power 4 plus 2 minus 6. That is what, guys? What's 4 plus 2? It's 6. What's 6 minus 6? It's 0. 4 plus 2 is 6. 6 minus 6 gives us 0. Then we can say 1 minus 1 plus, what's 5 raised to the power 0? It is 1. Now what do we have? We are now officially done with the brackets, the exponents, the division, and the multiplication. Now we can move on to the last bit of our order of operation. and that is addition and subtraction. So 1 minus 1 plus 1, we can add and subtract. What's 1 minus 1? It is 0. Plus 1 gives us the answer of 1. Okay. Thank you, Collie, for the rows. So all in all, guys, what we've just done, thank you so much, Collie. What we've just done is we've just figured out that the simplification of this, okay, 25 to the power 0, which is 1, minus 5 to the power 0, which is 1, because any base raised to the power 0 is 1. Okay, this is for grade 9s, okay, and also applicable to grade 8 because they do the same thing. Plus 5 to the power 4 times 5 to the power 2 divided by 5 to the power 3 to the power 2. This all, when simplified, needs to be followed. We need to follow the order of B, A, D, M, A, S, bad mass. And when we do so, we get the answer 1. So if we go back, the question was, what, question 10 there at the top, guys, what is the answer in simplest form? A, is it 1? B, is it 5? C, is it 21? D, is it 45? So we were able to calculate that indeed the answer is equal to 1. So if we are going to choose an option, we can now choose an option based on our calculation. So the option we choose is going to be what? It's going to be A. It's easy to select an option, especially if we have followed the proper procedure in calculating and followed the steps as we need to, and we are accurate. Okay, let's move on to question 11. Look at question 11. We are given 3 figures, okay, grade 9s, GEC 2022. Figure 1, figure 2, and figure 3. If you look at figure 1, okay, you can see that there are lines and there are dots, okay, and a hexagonal shape is formed. What do we mean by a hexagonal shape? It means we have a 6-sided shape that is formed with equal sides, but it is made up of dots and lines. So now question 11 says, how many dots will be in the next hexagonal prism? All right, so let's look first at figure 1 and try and count how many dots we have for each figure. That's where we need to first start. So if we look at figure 1, how many dots are in figure 1? Okay, because we need to write down a pattern based on the figures that we have. So figure 1, the picture 1 there that we have, how many dots do we have? I'm sure you can count those. We have 1, 2 at the top. Then if we move on to the next line, we have plus 3 of them, 1, 2, 3. Then if we move on to the next horizontal line, we have plus 2. So what's 2 plus 3 plus 2? 2 plus 3 is 5, and 5 plus 2 is 7. So for our first figure, we have 7 dots. Okay, there it is, 7 dots for our first figure. Let's move on to the second figure, figure 2. How many dots do we have? So we look at the top, we have 2 dots, 1, 2. We look at the next line, we have how many dots? Plus 3. So that means 2 plus 3 is 5. We look at the next line, we have 2, and then the additional 2 that are on the other side. So we have 2 plus 3, which is 5, 5 plus 4, which is 9, and then at the bottom, we have 2 more, which is basically 9 plus 2 is 11. So in our second figure, I'm hoping you guys can all see that we have how many dots? 11 dots. Then our last figure, figure 3, how many dots do we have? So if we count again, at the top we have 2, in the next line we have 3, so 2 plus 3 gives us 5. In the next line we have 2, so that means 2 plus 3 plus 2 gives us 7. But then on the side we have the other additional 2, so 2 plus 3 is 5, plus 2 is 7, plus those 2, okay, we have 9. Then we move on to the next row, plus 2 gives us 11, And then at the bottom, we have plus 4, which is 15. So 11 plus 4 gives us 15. So we have a number pattern from the figure that we have basically presented of 7, 11, and 15. This is very important, guys, that from the figures that you have, you need to be able to, as it says, how many dots will be in the next hexagonal prism. So we need to first establish how many dots we have in the 3 figures. And the question is, how many dots will we have in the next hexagonal prism? So Tando in the comment section has already answered, and the answer is based on what he sees as the constant difference. So guys, the question is, from 7 to 11, how much are we adding? Okay, so Tando has indicated in the comment section that we are adding 4. From 11 to 15, how much are we adding? We are adding 4. How do we know this? Because we can see that there is a pattern from 7 to 11 and from 11 to 15. So what do we refer to this as? We call this the constant difference, which is simply found by saying T2 minus T1, or we can say T3 minus T2. T2 minus T1, which means term 2 minus term 1 is 4. Term 3 minus term 2 is also 4. Thank you so much, Tando, for the rows. So that means we get a nice, beautiful answer. 11 minus 7, which is equal to 4. Which means if we want to get the next number, what are we going to do? We are going to add 4. What's 15 plus 4? As Tando said, we get 19. So this is our 4th figure. The 4th figure is going to have 19 dots. Thank you so much, Tando, for the 3 roses. I really appreciate it. It means a lot. Okay, Tando, don't worry. It will be posted definitely on my YouTube channel. Can you please make a YouTube? Don't worry. This I will save. I will post it on my YouTube channel as I am presenting it to you. So the link is in my bio for the YouTube channel. It will be available for you to watch at your own time when you are ready. I understand a lot of you are going to school. So I hope this helps us understand how we got how many dots. 19. Now if we go back to our multiple choice questions, how many dots will be in the next horizontal prism, hexagonal prism, sorry? A, is it 19? B, is it 24? C, is it 25? Or D, is it 28? Very clear, guys, that based on our working out, okay, we counted the dots in figure 1, there were 7. We counted the dots in figure 2, they were 11. We counted the dots in figure 3, they were 15. And then we figured out what is the pattern that is there for 7, 11, and 15. We found out that, hey, there's a pattern of plus 4. In other words, there's a constant difference. Because when we say term 2 minus term 1, we get 4. Term 3 minus term 2, we get 4. So basically that means there's a constant difference, which means this is a linear pattern. This is a linear pattern. So to get the 4th term or the 4th figure, how many dots are in the 4th figure? The constant difference that we have, which is 4, we continue adding that 4 to the 3rd term so that we get the 4th term. So therefore we know that the 4th figure will have 19 dots, and therefore our option that we choose based on the multiple choice is option A. Clear? I hope it's clear. Let's go to the next question. Question 12. We have A, we have 4, we have 1, we have 1 over 4, we have B. The question says there, what are the values of A and B? Option A, is it 8? All right. Is A equal to 8 and B equal to 1 over 8? Is it B, A is equal to 16 and B is equal to 1 over 8? Is it C, A is equal to 16 and B is equal to 1 over 16? Or is it D, A is equal to 4 and B is equal to 1 over 4? All right. So let us look at the values that we have there. It's a pattern A, 4, 1, 1 over 4, okay, and b. Right? Okay, Tando, that problem of solving for x, those are problems that are coming up in this 2022 GEC. So as I do these, then the next few problems, the solve for x will come up, and that will also be sorted. So when you do watch it, I'm sure you'll be able to see those problems related to that. But thanks for actually notifying me that's your problem, and I will definitely prioritize that in future videos so that that is clear for you. Hopefully you guys subscribe to the YouTube channel when you go to the link itself in my bio, so that future videos that get uploaded, you can get them. Okay, so let us just for a moment remove this. So here we have it, a 4 1 1 over 4 and b. Guys, let's see. It seems like here, if you can look at this, there is a particular number pattern that we are seeing here. We want a and we want b. So let's first check what's happening here. From 4 to 1 and from 1 to 4. What type of pattern is this? We discovered that the previous one was a linear pattern, meaning there was a constant difference. But guys, what's happening here? Okay, it seems like we are multiplying by 1 over 4. Because what's 4 times 1 over 4? That's what gives me 1. What is 1 times 1 over 4? That also gives me that 1 over 4. Okay. So I hope this is clear. Yes, Tyler. So the type of sequence that we are having here is the type of sequence that has what we call a constant ratio. A constant ratio, unlike a constant difference, is T2 divided by T1. Okay, so in other words, if you look at, or we can say T3 divided by T2, okay, or we can say T4 divided by T3. So this divided by that gives us 1 over 4. Does that make sense? So this is what we call our constant ratio. All right, yeah. So think about it now this way. What's 1 divided? Because if you're going in reverse, if we are multiplying, you're going forward, it means in reverse we are doing the inverse of this operation. So we can say 1 divided by 1 over 4. 1 divided by 1 over 4 is the same thing as 1 times what? 4 over 1. Because remember, when we are dividing fractions, if we are dividing, we can change the division to multiplication, and then what happens to the fraction? It inverts. Yes, it is grade 9. Okay, so it becomes 4 over 1. So that means 1 times 4 is 4. That's how when we say 1 divided by 1 over 4, we get this 4 back. We are interested in getting the value of a. So what are we going to do in reverse? What are we going to do in reverse? We are going to say 4, not times. Remember, when we are going forward, we are multiplying. But when we are going in the opposite direction, we are dividing. Okay, so 4 divided by 1 over 4. Just like, guys, 1 divided by 1 over 4, we were able to get 4. Now we are going to say 4 divided by 1 over 4 because we are going in the opposite direction. So if we say 4 divided by 1 over 4, that's the same thing as 4 times 4 over 1, which gives us an answer of what? 16. So my a value is 16. Okay, hey, I hope we are together here, guys. I hope we are all flowing together with this. All right, so with a constant, with a number pattern that has a constant ratio, let's understand that as we move from the first to the second term, there's a certain constant ratio we are multiplying by to get the next value. We multiply by a constant ratio consistently because this type of pattern is the one that has a constant ratio, grade 9s. Does that make sense? But if we are moving, in reverse, meaning we are moving backwards. Then from here, to get back to this, we divide by the same value. Okay. It's true, Mbokozo, it's true. Tyler, you're 100% correct. All right. Imagine if grade 9s understood that this is like their basic foundation for later grades. Then grade 9s would master this and they would do very well in grade 12. But yeah, sometimes maybe teachers fail to actually make that clear to grade 9s, and maybe grade 9s are too playful or too childish to actually realize or recognize that this is very critical for grade 12, later on in life. So A, guys, we can agree is 16. We want B as well, remember? So we are going to continue. We know we are timesing by 1/4. So this one is going to be in the forward direction. In the forward direction, 1/4 times 1/4. This one is clear. 1/4 times 1/4, is equal to what? What's 1 times 1? It is 1. What's 4 times 4? It is 16. So that means B is equal to 1/16. So we are clear. A is 16. B is 1/16. No problem there. So if we go back to our page, number 12, what are the values? If A1 or A4, 1/4 B, what are the values of A and B? Guys, if you're answering number 12, as I have pointed out to you, it becomes firstly important for you to know what kind of pattern you have. Then 2, after discovering the pattern, what kind it is, then you need to be able to use, if it's a linear pattern, use the constant difference to get the other values. If it is a geometric pattern, then you use the constant ratio. If it is the type of pattern that has a constant ratio, you use the constant ratio to get the other values. So we can see there that the answer is going to be, as Tyler said in the comment section, it is C. All right, that is our answer. C is the answer. A is equal to 16 and B is equal to 1/16, as I have explained. Okay, we can now move on to the next question, guys. That one was a meal and a half. Okay, number 13, question 13. Let's look at question 13. Tyler is saying, please do a quadratic sequence. Remember, Tyler, if I did a quadratic sequence, that would be outside the grade 9 syllabus. Okay, what grade are you in, Tyler? I'll do a quadratic sequence if you can show me that. What grade are you in? Just let me know in the comment section, and then I might just steal 10 minutes and do a quadratic sequence if like it is really something that you're done with school. Yeah, if you're done with school, Tyler. Tyler, hi. When are you happy, Moss? What are you doing? What are you studying at the moment? Chill. This one. Okay, let's look at number 13. Arrangement 1. Okay, guys, we have arrangement 1, arrangement 2, and arrangement 3. And what does it say? It says tables and chairs are arranged such that in every second arrangement, the tables are not joined. No problem, Tyler, it's okay. Tables and chairs are arranged such that in every second arrangement, okay, the tables are not joined. Guys, as you can see, in arrangement 1, okay, there's that single table. There's 4 people that are seated there. They are enjoying a meal together. So if they are saying in every second arrangement, so in the second arrangement, as you can see, the tables are not joined. There's 2 separate tables, and you can see how many people there are in that table. There are 8 people, and they are enjoying their meal together. Let's look at arrangement 3. In arrangement 3, guys, you can see the tables are joined. But clearly in arrangement 4, the tables will be not joined. So now what they are saying there is tables and chairs are arranged such that in every second arrangement, the tables are not joined together. Then they say the arrangements indicate the number of people that can occupy the tables and chairs. So here we are interested in what? The number of people that occupy the tables and the chairs. So they are asking now, what is the rule to determine the what? The number of people for the what? For the seventh arrangement. We are looking for the what? The rule to do what? To determine the what? The number of what? Of people for the what? For the seventh arrangement. So here we are not wanting the number of people in the seventh arrangement. We want the rule. So they've given us options there. A, is it 7n? B, is it 4n? C, is it 12n? Or D, is it 16n? So let us first write down the pattern that is coming from the people that are seated in the table. So in arrangement 1, how many people do we have in arrangement 1? We have 4 people. What about in arrangement 2? How many people do we have? You can count them. 1, 2, 3, 4 in the first table. 5, 6, 7, 8 in the second table. So in total, 4 in the second table as well. In total, in the second arrangement, we have 8 people. Then in the third table, how many people do we have seated there? We have 1, 2, 3, 4, 5, 6, 7, 8. All right. So we have what? 8 people. Okay. 8 again. I hope that makes sense, guys. So in the first arrangement, in the second arrangement, in the third arrangement. Now I want you to note something very, very critical. Okay. They wanted us to determine what is the rule to determine the number of people for the seventh arrangement. Okay. So I want you to be clear here that for the seventh arrangement, we are talking about the odd arrangement. We're talking about the what, guys? We are talking about the odd arrangement. So in other words, we are looking at 1, 3, the fifth arrangement, the seventh arrangement. This is very important. So I wanted to ask you guys, in the fourth arrangement, how many people will I have seated? Remember, in the fourth arrangement, this is where the tables are what? The tables are separate. So how many people are we going to expect to be seated in the fourth arrangement? I want you guys to tell me. Okay, I, in the diagram, have one arrangement, the arrangement 1, 4 people. Arrangement 2, I have 8 people. In arrangement 3, I have how many people? I have 8 people again. So in arrangement 4, how many people will I be having seated in that table? Maybe it will be also important to actually do what? To actually write down how many tables there are. So we know there's going to be 1, but this time around the tables are going to be separate. 2, 3. All right. In that arrangement, do we all agree how many tables will there be there in arrangement? Okay, look at the table. In arrangement 1, there's 1 table. In arrangement 2, there are 2 tables. In arrangement 3, there are 3 tables. So in arrangement 4, how many tables will we have? 4. But those tables will be what? Separate. Why? Because we are told tables and chairs are arranged such that in every second arrangement, the tables are not joined. In every what? Every second arrangement. So here we have separate. Here we are also going to have separate tables. Does that make sense, guys? Read the question. Read the question. That's why I'm saying for GEC grade 9s, please people, you need to open your minds. Don't just take for granted. Okay. Now, if I was to draw the people that are seated, nice meal, nice meal, nice meal. He's going to be seated there, this guy, eating. No? Does that make sense, guys? Okay, do you see? So how many people are there seated? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Is that true? Hey guys, do we see this? Oh no. Remember, sorry, I didn't open enough. You see, even me, I'm messing up here. Sorry guys, my mistake. Do you see the mistake I made? I hope you guys see the mistake I made here. This is supposed to be there, and there. Okay, yeah. Okay, sorry for that beautiful mistake. I hope my mistake does not ever become your mistake. You let my mistake be a lesson for you, and then let my lesson for you be something that you know then to do next time. Okay, so do we see, do you see this big mistake that I made here? All right, but do we see now the correction of the mistake? Okay, because this is a table, there should be 4 people seated here. In each table there's going to be 4 people, so 4 times 4 obviously is going to be how many people? We have 16. So does that make sense? So 16. Okay, and then remember, in the next table it's obvious we are going to have 16 again. Okay, and then in table 6, all right, we are going to have another number. Okay, and remember this time round, because 1, 2, 3, 4 tables, 5 tables, 6 tables. Okay, 6 tables. Is that correct, or am I mistaken? So we have 16. If we do we all agree? So obviously that's 16. If we join, because remember now in the 5th table we are going to join. All right, in the 5th arrangement we are going to join 5 tables, and then we are going to have people seated. You see? Yeah, so now we're going to join. For the 5th arrangement we join. Do we have 16? Is it 16? Yeah, so the 4th arrangement, that's how it is. 5th arrangement, 1, 2, 3, 4, 5 tables are joined. Then we have people seated around the table. Right, this is our 5th arrangement. So how many peoples do we have there? 1, 2, 3, 4, 5. All right, then we have people seated around that particular table. So how many people do we have there? Yeah, because we join the tables, mas. Yeah, because in the 5th arrangement, okay, remember we are going to join the tables. We join the tables. Yeah, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means we're going to have 12 individuals here seated around this table. Very important. Then we go to our 6th arrangement. In our 6th, so yes guys, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're going to have 12 people seated in that table. Okay, very important there. Okay, yeah. Then in our 6th arrangement, guys, what's happening in the 6th arrangement? In the 6th arrangement, we are again going to separate 6 tables. Okay, And remember, if we are going to separate 6 tables, that means we're going to have 4 people seated in each table. 4 people seated in each table. Okay, so what's 4 times 6? Obviously, you guys should know what 4 times 6 is, because we have 4 people seated in each table. 4 times 6 will give us 24. So there's the 24 people. Then on our 7th table, remember, we are going to take the 7 tables and put them together. So I'm sure you guys will understand how many people will be seated there around that table. 1, 2, 3, 4, 5, 6, 7. Okay, guys, the reason why I'm doing this out is so that you guys can see that GEC, when you guys answer these GEC questions, these multiple choice questions, you need to do your working out on the side and then select an option after doing the working out. So 1, 2, 3, 4, 5, 6, 7. There are 7 tables. People seated, obvious. Okay, right? I'm just rough writing this. And I know you guys can count, obviously, you know. Yeah, 7 times 2 is 14 plus 2 will give you 16. Okay, now what I want you to notice then, guys, is that for your odd arrangements, 1, 3, 5, 7, 1, 3, 5, 7, there is a pattern that we are seeing with the odd arrangements. Okay, so our odd arrangements give us 4, 8, 12, 16. We get a pattern from the odd arrangements. And remember, it was from the 7th. They said there, what is the rule to determine the number of people for the 7th arrangement? So that is the thing. After writing down all my arrangements, for writing the number of people for each arrangement, I am noticing here that 4, 8, 8, 16, 12, 24, 16. Okay, those are numbers of the people, but there are specific patterns that I see between 4, 8, 12, 16. All right, this is a specific pattern that is formulated from the odd arrangements. But then there's another pattern formulated from the even arrangement, 8, 16, 24. All right, so there's a constant difference here for the even arrangements of 8. But there's a constant difference of what? Of 4 between the odd arrangements. Okay, I hope that makes sense, guys. Okay, so yeah, so that is very, very important. 2 patterns, all right, but that is something that you will only be able to see if you are able to see what you need to see. So these are 2 linear patterns. They are arithmetic, yes, if you are a grade 12 learner. Okay, linear, arithmetic, there's a constant difference, but they are separate patterns. The even arrangements, 2, 4, 6, those even arrangements have the number of people form a linear pattern that has a constant difference of 8. But then the odd arrangements, 1, 3, 5, 7, they also form a linear pattern, but there's a constant difference of what? Of 4. So if we now want to find out what is the rule to determine the number of people for the 7th arrangement, then we need to look at this pattern. Okay, and then if we want to find the rule, what do? We know first and foremost, we find the constant difference. Okay, which in this case will be 8 minus 4, which is 4. That is D. Okay, then we say Tn is equal to Dn plus C. Okay, and then D stands for constant difference. The N means position. The C is just a constant. So Tn here, we can choose any pattern here. 4, 8, 12, 16. Okay. And then what we can do is we can say Tn is equal to 4n plus C. In order to find C, there's 2 ways you can find C. There's a formula, guys, that they say C is equal to T1 minus D. You could use that. So your term 1 here is 4 minus the constant difference, which is also 4. 4 minus 4 gives you 0. So C is equal to 0. Therefore, you say Tn is equal to 4n plus 0, which therefore means Tn is equal to 4n. This is your general term to find. This is your rule to find the 7th arrangement. Tn is equal to 4n. Okay? Or to find the C value, you could basically choose one of the terms in the sequence, whatever term. You could say Tn is equal to 4n plus C. We know how we found the D, which is the constant difference. We said T2 minus T1, no problem with that. Then you can say Tn is equal to, you can choose a term, any term. Let's say we choose term 12. That means in the place of Tn, we write 12. What position does 12 occupy in this pattern? It occupies the 3rd position. So we then say 4, in the place of n, we write 3 plus C. Then we solve for C. So 12 is equal to 12 plus C. We transpose the 12. We know that C is equal to 0. Therefore, we say Tn is equal still to what? To 4n. Because remember, in the place of C, we know that C is 0. So therefore, we can say Tn is equal to 4n. So these are 2 different ways to find the C value. You can either find the C value using this formula. C is always going to be equal to term 1 minus the constant difference. That's how you can find the C value. All right. And then once you find the C value, go and substitute it back in the place of C. We know that Tn is equal to 4n. Or to find C, you can choose any term in the sequence. Write it in the place of Tn. In the case here, I wrote 12 in the place of Tn. Then I ask myself, what position, remember n means position, what position does 12 occupy in my given sequence? It occupies the 3rd position. So in the place of n, I substitute 3. Why do I substitute 3? Because the position 3 is for the value of the term, which is 12. Let's say I had chosen 8. If I had chosen 8, I would write in the place of n, 8 is in the position of what? Position 2. So I would write 2 here. So it would be 8 is equal to 4 times 2, which would also lead me to the same answer, C is equal to 0. Or I could choose 16, which is 16 is in the 4th position. You see? So whatever term value you choose, you write its position here, and then that allows you to solve for this unknown value, C. Once you get C, you substitute it back into the general term. This is your rule. So what is the rule, guys? To determine the number of people for the 7th arrangement, there it is. It is B. It is B. Okay. Okay. I hope we are together there. I really hope we are together and we are flowing together very nicely. Okay. All right. I don't know if there's any questions in particular, any questions that are arising from this. Yeah, so this, guys, is really, really something that, grade 9s, as you prepare for writing GEC, final exam, paper 1, you must make sure, guys, those who are writing GEC, multiple choice, that you do your working out at the on the side, and then you come and select the right option. So I would come now and select B. All right, because my rule is 4n, it's nothing else. Maybe some of you would be able to get the rule by inspection. Okay, and that's also totally fine, because maybe you would see that for your odd arrangement, you have 4, 8, 12, and you know that the rule that you basically use to get the 7, the next and the next term would be 4n. That's also perfectly fine if you are able to do that. Okay, all right. Okay, so I hope we are together there. Yeah. Any questions that you have, please, you can always ask them. Guys, I want to turn our attention now. I'm going to skip question 14 for now, and I'm going to do it in a future live lesson. I just want to fast track now and do 15. Okay, so 15 there is an algebraic expression question, because I'm trying to, in this live, before I leave, actually get to equations, because someone had indicated, Tando, who was here, indicated that that's something that he wants attention to. So I just want to fast track it a bit so that I can get there. It's in the next questions that are coming up. 15 says, what is the coefficient of x squared? You have x to the power 4 plus x to the power 3 minus x squared in brackets, and it's divided by 4. And then the question is, what is the coefficient of x squared? What is the coefficient of x squared? Is it A, 1, B, -1, C, -1 over 4, or is it D, 1 over 4? That is the question. What is the coefficient? Question 15. What is the coefficient of x squared? There in brackets you have x to the power 4 plus x to the power 3 minus 2 in brackets, and then it's divided by 4. And they're asking, what is the coefficient of x squared? Is it A, 1, B, -1, C, -1 over 4, D, 1 over 4? So what I would advise in a question like this is to actually write out this thing, x to the power 4 plus x to the power what? 3 minus x squared, right? And they said divided by 4. Now, very important that you understand the following. This is actually can be represented in the following way. This here in brackets means that all of this in the numerator is divided, all of it, by what? By 4. So we can rewrite this and express it as that in fraction form. Then you know that on the top you have one term when it is in bracket, but since it is actually at the top, all of it, you can remove the brackets over 4, and then at the top alone, the top alone consists of how many terms? 3 terms. And these 3 terms are separated by this plus sign and this minus sign. That's why I can count at the top. We have x to the power 4, that's one term, x to the power 3, that's another term, and x to the power 2, that's another term, separated by a plus and a minus sign. Remember, terms are separated in an expression. Terms are separated by a plus and a minus sign. And now what can you do? You can split these terms, okay, over this common denominator, which is 4. So I can write this as x to the power 4 over 4 plus x to the power 3 over 4 minus x to the power 2 over 4. What did the question say? What is the coefficient of who? Of x squared. So our focus is on this last term, the x squared term. The question is, what is the coefficient of this last term? Guys, what is a coefficient by definition? A coefficient is a number that stands next to that given variable. So if it's x squared that they are talking about, we are interested as to what is the number multiplied to x squared. Okay. The number multiplied to x squared, guys, we can clearly see is firstly a negative number. It's negative. At the top, there is a invisible 1. At the bottom, there is a 4. So that number, the coefficient of x squared, is actually negative 1 in the numerator, which is the coefficient of x squared at the numerator, over this 4, because the 4 as well is a coefficient of what? Of x squared. So the full coefficient is -1 over 4. This is the coefficient of x squared. So if we go to the options, is it A, 1, B, -1, C, -1 over 4, D, 1 over 4? It's very clear, guys, that our answer or our option that we choose is going to be what? It's going to be D. No, not D, sorry. It's C. Okay. All right. So I hope that makes sense. It is C, -1/4. Okay. Because we were able to take this expression, rewrite it into fraction form, because it is supposed to be in fraction form. This is x to the power 4 plus x to the power 3 minus x to the power 2, which is together, and it's all divided by 4. So that means that in the numerator we write this expression, we divide all of it by 4. Then we separate or split the terms according to the common denominator, and then we identify the coefficient of the x squared term, which is -1/4. Had they asked us for the coefficient of the middle term, it would be, if the x cubed term, it would be 1/4, +1/4. If we had been asked the coefficient of x to the power 4, it would also be 1/4, that is positive. But since we are asked the x squared term, the coefficient of the x squared term, it's -1/4. So we choose the option C for number 15. Okay, let's move on to the next question. Okay, number 16. Number 16. 4ax² plus 3axy minus 14ax plus 7xay plus x squared. Which of the following are like terms in the expression? Grade 9s. Which of the following are like terms in the expression? So hopefully we have not forgotten, grade 9s, what like terms are. What are like terms? Hopefully we have not forgotten. Like terms are terms that have the same letters. Okay, the same letters. So for instance, let's look at this. What's happening, man? It's blurring out. 4ax², axy. So far we have different things here. Ax, nothing is common or the same so far. Xay, x, a, y. We have the same things, right? They may be ordered differently, but we know that multiplication is commutative. In other words, xay is the same thing as axy. The order of the letters for multiplication does not matter. It does not disqualify those being like terms. Those are still like terms. Why? Because the x, there's an x. There's a y, there's a y. There's an a, there's an a. They are all having the same letters. It's like the same school uniform, right? Yeah. x², nothing else has x² alone. So the like terms, guys, has to be those two. Positive 3axy and 7xay. So if we go to our options, which of the following are like terms in the expression? A, 4ax² plus x²? No. B, 3axy minus 14ax? No. C, 7xay minus 14ax? No. D, 7xay plus 3axy? Definitely. So our option there is correct. It is D. The correct option is definitely going to be D, nothing else. Let's go to question 17, guys. Question 17. Question 17, we are given 2x minus 3y into x plus 5y. And then the question is, what is the product? So let's first analyze this. When they say what is the product, they mean, product means multiply. Thank you so much, Tando, for the rose. Product means multiply. Okay, what is the product? So what we are going to do is we are going to write down the 2x minus 3y. with the brackets into x plus 5y. Then they are asking for the product. So that means what? We are going to apply the distributive law using FOIL. Okay, the distributive law using FOIL. And when we apply the distributive law, let's not forget that when we multiply S and L, we multiply the sign, we multiply the number, we multiply the letters. Okay, so let's distribute. We distribute the first terms first by multiplication using sign. When we multiply the sign, we multiply the number, we multiply the letter. Positive times a positive, that obviously will give us something that is positive. Then we move on to the number after the sign. 2 times, remember the coefficient of x here is 1. 2 times 1 is 2. Then x times x, we move on to the letter. X times x, remember guys, if the variables are the same and we are multiplying, what do? We keep the base. The exponents there are 1, so 1 plus 1 gives us 2. So we have 2x squared there. 2x, the outer terms, 2x times 5y. You see the 2x is being distributed to x, and then the 2x is being distributed to 5y. After we are done with 2x distributing it to the two terms, we take negative 3y, we do the same thing. We distribute him to the two terms as well. How? By multiplication. Using what? We multiply the sign, we multiply the number, we multiply the letters. Very important, this thing. Okay, so we've done with this. Let's multiply that with this. Positive times a positive gives us a positive. 2 times 5, the number gives us 10. X times y is xy. Remember, when we're multiplying two letters that are different, we combine them when we multiply. We're done with distributing to x. Now it's time to distribute negative 3y into x and then negative 3y into 5y. Let's start here. Sign, number, letter. Negative times a positive is negative. 3 times 1 is 3. Y times x. Remember, we said the order of the letters with multiplication doesn't matter. So we just say xy so that we can see, oh, these are like terms. Then negative 3y, we multiply with positive 5y. What's a negative times a positive sign? Gives us a negative. 3 times 5 number, 15. Y times y, our letter, we get y. Remember, we're multiplying same bases. So when the bases are the same and we're multiplying, what do we do to the exponents? We know there's 1 and 1. What's 1 plus 1? We get y squared. Okay. Then we add the like terms. 2x squared is an unlike term. Nothing is like it. So nothing is going to be added to 2x squared. 10xy minus 3xy. When we have like terms, we obviously keep the variable xy. We add the coefficients or subtract them. What's 10 minus 3? That's plus 7. And then minus 15y squared. This is our answer. Now, we double check. We make sure that the answer is really accurate. We've multiplied our signs correctly, our numbers correctly, our letters correctly, and we've added like terms correctly, and we've applied the law of exponents as needed for same bases. That is the answer. Let's go to check our options. What is the product? Is it A, 2x squared plus 7xy minus 15y squared? It is, guys. The answer I have there is similar to what I see for A. B, C, and D, though close they are all out. So I know that I did my multiplication correctly. So my answer that I'm going to select for my multiple choice is going to be A, because I've worked it out and it's accurate from what I can see. Okay, let's move on to 18. What is the expression in its simplest form? 16x cubed minus 2x into minus 3x minus x in brackets over negative 2x squared. What is the expression in its simplest form? All right. What is the expression in its what? Simplest form. So now I am going to have to go and apply my knowledge of simplification of expressions. And I consider when I do this, my understanding of BODMAS. So guys, let's come here. 16x cubed minus 2x into minus 3x minus x over minus 2x squared. So let's first focus on the numerator and simplify what we have there. Obviously with our knowledge of who? Of BODMAS. So first thing I like always asking when I'm simplifying terms in an expression, in the numerator, how many terms do we have? That's the first question I usually ask myself. How many terms do I have in the numerator? So 16x cubed is one term, minus, then 2x into minus 3x minus x. This is a separate term from 16x cubed. All right. So I can see that 16x cubed must just stand there for now and wait. But negative 2x brackets, remember this means I can distribute this 2x into these terms. But let's first check in the bracket what's happening. We have like terms. So if I have like terms inside my bracket, that means I can add and subtract like terms. According to BODMAS, okay, I can actually add or subtract like terms. These are like terms as I can see, guys. I'm sure you can see from the question, this was negative 3x minus x. So these are like terms, okay? So you can distribute if you want, don't change anything, or you can just add and subtract the like terms, then multiply negative 2x with what you get there. So negative 2x in brackets, negative 3x minus 4x is negative 3x minus x is negative 4x. You keep the variable when you are adding and subtracting like terms, which is x, and then you add and subtract the coefficients. What's minus 3 minus 1? Minus 3 minus 1 is minus 4. Okay, if you are ever at loss, use your calculator. So therefore the answer in the brackets is minus 4x over what? Over 2x squared. Then I continue, 16x cubed. Now I can multiply these two because brackets mean multiply. And according to BODMAS, remember, brackets, I sorted out, I got negative 4x. Exponents, no. Division, no. For now, division, even though there's a line, I'll wait. Multiplication, we can multiply these two because multiplication comes before subtraction or addition. So 2x times minus 4x. Negative times a negative is positive. That's the sign. Then the number 2 times 4 is 8. Then the letter x times x is x squared over what? Over 2x squared. Now remember, guys, there's a few ways you can do this question when you are here. It's really up to you what you decide. All right, but you can factorize if you want the numerator, take out the common factor, and then you actually simplify. Or you can split the numerator, okay, into its common denominator, and then you can simplify. So it's really up to you how you decide. So let me just approach these both in the respective ways. So let's say I use the grade 8 method and I split. If I split, I'm going to say 16x cubed over 2x squared plus 8x squared over 2x squared. That's how a grade 8 learner would do this question. Then you do what? You simplify each fraction. Using S and L, you are going to divide. Positive divided by positive is positive. 16 divided by 2 is 8 for the number. So sign, positive divided by positive is positive. Sign, number, 16 divided by 2 is 8. Then the letters. X to the power 3 divided by x to the power 2 is the same thing as x to the power 3 minus 2, which is x. Okay, yeah, x to the power 1. The bases are the same. You are dividing. What do you do to the exponents? We subtract. Or you can say there are 3 x's here, there are 2 x's there, so the 2 x's will cancel. You'll be left with 1 at the top, 1x. Okay, so that's why the answer is 8x. Then come here, positive divided by a positive, that is also positive. 8 divided by 2, that is 4. That's our number. Then the letter x squared divided by x squared, those would both cancel out. Or you can say x squared divided by x squared is the same thing as x to the power 2 minus 2, which is x to the power 0, which is 1. So this is the same thing as 4 times 1. Final answer, 8x plus 4 times 1 is 4. So you get 8x plus 4 as your final answer. Okay, so this is simplification of expressions. Okay, so this would be how a grade 8 learner would approach it, and a grade 9 learner would obviously also can be in the position of using this approach where you split according to the common denominator. Remember, the splitting only happens if there are terms in the numerator, okay, and you can divide each respective term by the common denominator by splitting it. 16x cubed over 2x squared plus the plus sign, 8x squared divided by 2x squared. Then you apply division using S and L. S means sign. You divide the signs. Positive divided by positive is positive. You divide the numbers. 16 divided by 2 is 8. You divide the letters. X cubed divided by x squared, as I showed you, gives you x. Then you do the same thing with this fraction. Positive divided by positive is positive. 8 divided by 2 number is 4. And then x squared divided by x squared gives you 1. You get 8x plus 4. All right. Grade 8 method. If you are in grade 9, alternatively, the same expression, 16x cubed, you could do in the following way. 16x cubed plus 8x squared over 2x squared. If you are in grade 9, you've done factorization. So in the numerator, there is what we call a highest common factor that you can take out. Remember, factorization in grade 9, you have highest common factor factorization. So when you take out the highest common factor, you also apply S and L. If you want to take out the highest common factor sign, you check this term. Firstly, how many terms? There are 2 terms. This term, the first term, you take out the sign of the first term, whatever it is. So the sign of the first term is positive. So that means I'm going to be taking out a highest common factor sign that is positive. Number 16 and 8. What is the highest common factor between 16 and 8? Do we know? What is the highest common factor between 16 and 8? In other words, what number can I take out? The highest number that I can take out between 16 and 8, which is a factor of both 16 and 8. Is it 2? Is it 4? Is it 8? Is it 16? Okay, so hopefully we all know that the highest common factor number is 8. Then we go to the letters x cubed and x squared. Remember, when we take out the highest common factor letter, we take out the common base with the lowest exponent. So the highest common factor letter variable is going to be x squared. Then I open brackets. So that means my highest common factor is positive 8x squared. There it is. Then if I take out 8x squared, what is left? 8 times what gives me 16? It is 2. Or you can say 16 divided by 8 is equal to what? 2. Do you see this? 8 times what gives me 16? It is 2. Or you can say 16 divided by 8 is what? It's 2. You took out x squared. You took out 2 x's. You need to have 3. How many x's are left? You took out 2 of the x's. You need 3 of them. How many x's are left over? There's only 1 x that's left. So that means 2x there. Okay. X squared times x anyways should give you back x cubed. So that makes sense. Then positive times what gives you a positive? It's positive. Then you have 8x squared you've taken out. You need 8x squared. So 8x squared times what gives you 8x squared? It's 1. All over 2x squared. When you have a situation like this, there's a product at the numerator. In the denominator, you have 2x squared. So what you can do then is you can ask 2 and 8. 2 2 and 8. What is the highest common factor between 2 and 8? It's 2. 2 goes into 2 how many times? Once. 2 goes into 8 how many times? 4 times. X squared and x squared, you can cancel out. You are left with 1. So finally, we have 4 into 2x plus 1 over 1. But we know that 1 in the numerator doesn't matter. We have an answer now of 4 into 2x plus 1, which gives us 8x plus 4. This is the same answer that you had gotten when you were doing the problem as in the grade 8 approach. Okay, this is a potential grade 9 approach you could use using factorization. All right, so this is the same answer that you had gotten when you used the grade 8 approach by splitting the fraction, because you have one common denominator and then terms in the numerator. So it's really up to you how you proceed. Let's go back now and check in our options. Which option will we choose? What is the expression in its simplest form? Is it A? Is it B? Is it C? Is it D? We have a definite answer, guys. There it is. We worked it out. So now it's easy to select an option that it's going to be A. You see, we get A. A is the answer. All right. Okay, next question, number 19. What are the factors of the expression? Here is the expression 1 minus 9a squared. What are the factors of the expression? So once again, this is factorization. And in factorization, we did say that there is the type of factorization that we call highest common factor, but here we have a different type of factorization. The type of factorization that they refer to as dots, which means difference. What is difference? Difference means minus. You can see the minus sign here. That's difference. Of 2. There's 2 terms, 1 and 9a squared. 2 what? 2 squares. What do we mean by squares? 1 is a perfect square. What do we mean by a perfect square? Perfect squares are numbers that we achieve by multiplying a certain natural number by itself. For instance, if we multiply 1 by itself, we get 1. 1 is a perfect square. If we multiply 2 by itself, we get 4. 4 is a perfect square. If we multiply 3 by itself, we get 9. 9 is a perfect square. These are perfect square numbers because they are formed by multiplying a number by itself. So these are what we call perfect squares. So as you can clearly see, this is truly a difference. Difference means minus. Of what? 1 is a perfect square, which is clear from what we can see. 9, the number, is also a perfect square, which we can clearly see. And a squared is also a perfect square because a squared is formed by a times a, multiplying a by itself. Do you see this? So what we do with difference of 2 squares, if we are factorizing it, we open. If there's no highest common factor, because in all questions that are factorizing, we always ask, is there highest common factor? The highest common factor between 1 and 9a squared is 1, right? So that's always going to be outside. But because of this particular situation we have here, okay, highest common factor is 1. All we simply do is we open 2 brackets because we can see that the highest common factor is 1. So that allows us to open 2 brackets immediately if the highest common factor is 1. But if the highest common factor is another number, we take out that number and first write down the terms that result because of taking out the highest common factor. In this situation, the highest common factor is 1. It still leaves us with 1 minus 9a squared. Now, what we do when we are finding the terms inside the 2 brackets, which are the factors, we first write down 2 different signs. Guys, this is always the case. You write down 2 different signs, 1 bracket that's plus, 1 bracket that's minus. You take the first term, you ask, what is the square root of 1? It is 1. So in the first position, in the first term of each bracket, I'm going to write 1 and 1 because 1 times 1 gives me 1. Then in the last position, what is the square root of 9a squared? The square root of 9a squared. The square root of 9 is 3. The square root of a squared is a. Okay, so that means the square root of 9a squared gives me 3a. So that means in the last term for each bracket, I'm going to write 3a, 3a. Can I factorize these two brackets independently any further? No, that's where it ends. So my answer is 1 plus 3a into 1 minus 3a. You must always check, guys, that after you factorize, is there further factorization that should still be done? If not, then it means you end right there. Okay, but if there's still factorization that can be done, you continue factorizing. But here, that is our answer. So if we go back to our options, what are the factors of the expression? Is it A? No. Is it B? Definitely. Is it C? No ways. Is it D? No ways. We can see that our answer that we got aligns with B. Our answer that we got aligns with B. So we are going to select the option who? B. That's the answer. Okay. Right. Moving right along. Let us go. 20. All right. And I'll most probably end here at 20 for today because I have to head out. 3x cubed plus 9x squared minus 30x. What are the factors of the expression? 3x cubed plus 9x squared minus 30x. What are the factors of the expression? So we need to factorize. So here, first and foremost, the first thing we always check when we are factorizing, we ask, is there a highest common factor? And remember, when I said the highest common factor, we check the highest common factor sign, we check the highest common factor number, we check the highest common factor letter. Highest common factor sign, the first term which has the highest degree of the expression is positive. So that means our highest common factor sign is positive. Let's go to number. Highest common factor number between 3, 9, and 30. What is the highest common factor number? The number that goes into 3, that goes into 9, that goes into 30. The highest number that goes into all of these numbers is what? Between 3, 9, and 30. It is 3. 3 goes into 3. We know how many times. So, but it is 3, guys. Then lastly, letters. X cubed, x squared, and x. Remember I said for highest common factor letter, we always go for the common base that has the lowest exponent. So between x cubed, x squared, and x, our highest common factor is the one that has the lowest exponent. So it has to be x. We are done taking out the highest common factor. You write the highest common factor on the outside, you open brackets so that now you can fill in what is remaining. 3 times what is 3? It's positive 1. You have 1 x that you took out. You need 3 of the x's. How many x's do you need to have? 2. Because remember, when bases are the same, you are multiplying. What do we do to the exponents? We add them. There's 1 plus 2, which will give us back the 3. That's fine. 3 times what? You have positive. Positive times what gives you a positive? It's a positive. 3 times what gives you 3? It's 3. You have 1x. You need 2. How many x's do you need to add? Just 1. You see? 3x times negative 30. 3x times what gives you negative 30? 3 times what gives you negative 30? It is negative. Positive times what gives you a negative? It's negative 10. There's 1 x taken out. I need an x. Do I need to write another one? No. So that's the first ring of factorization I do. Then I can now open 2 brackets. Because my coefficient of x squared is positive, I open 2 brackets. Now I'm going to look for the factors of 10, okay, that have, now firstly, we have a negative sign for the constant. What does that mean? It means I'm going to have different signs in my bracket. A negative constant term means I'm going to have different signs in my bracket, as long as the x squared is positive. If I had a positive constant term, it would mean I'm going to have the same signs in my bracket. That's what you need to understand. Minus means different signs. If there was a positive constant term, it would mean I'd have the same signs inside the bracket. Now, look at this. Different signs. If the signs are going to be different, the factor in my bracket that is the highest is going to have a positive sign. So I'm going to ask myself, what are the factors of 10? Which when I multiply, give negative 10. But when I add, they give 3. Right? So what are the factors of 10? There's 10 and 1. There's 5 and 2. What did we say as well? That if the sign here is positive, it means that my highest factor here will also be positive. Whereas I'm going to have different signs, but the highest factor needs to be positive. Guys, if it was negative and then another negative, it would mean that my highest factor needs to be negative for the different signs. Okay? So remember, I'm repeating, minus means you're going to have different signs in the bracket here. But the highest factor, because this is a positive sign, the highest factor is going to have a positive sign. If there was a negative and another negative, it would mean still different signs for the negative constant term. But then if there was a negative here, it would mean my highest factor needs to be negative. So highest factor is going to be positive. So I'm going to place positive for the big numbers and then negative for the small numbers. If I multiply this, I get the negative 10. If I multiply that, I get the negative 10. But which one, when I add, gives me the positive 3? Is it 10 minus 1 that gives me positive 3? Or is it 5 minus 2 that gives me positive 3? So it is this one. Okay. So inside my bracket, guys, I'm going to say 5 minus 2. Then I'm going to write x, and I'm done. There is my factorization. That is my answer. I go to my options. I look at my options. What are the factors of the expression? Is it A? No. Is it B? No. Is it C? Definitely not C. Is it D? Definitely it's D. So the answer, grade 9s, is D. Okay? Hey, you guys. All right? Now, unfortunately, even though you guys are sharing the live so much now, I have to leave. Okay? Thank you so much for joining the live, guys. This is now from question 10 to 20 of GEC Paper 2. Paper 1. From the 2022 GEC paper that was written by grade 9s. All right? So, I will upload this onto the YouTube channel. The link is in my bio. Please go to the YouTube channel, click on the link. If you can't actually click on the link and go to the YouTube page directly, you can always copy the link, post it on your Google search engine, and then search for it, and then you can go to the YouTube channel. Subscribe, guys, because I'll be continuing with the rest of the GEC questions tomorrow. All right, I've done question 1 and 9. The video is already on my YouTube channel. You can find it there. Okay, for the 2022 paper. Now I've just completed doing question 10 to 20 of the GEC paper 1 that was done in 2022. I'm going to also upload it during the course of the day. Then tomorrow morning, 5 o'clock, 10 past 5 in the morning, same time, up until 7, I'll be doing from question 21 continuing onwards. All right, and hopefully, guys, before you even write, way before you even write, I'll be able to do 2023, I'll do 2024, and I'll do the live lessons here, so that you guys are more than welcome to share the live and make sure that others notify them. Thank you so much. I hope you guys have a great day. Thank you for those that joined and those that answered, those that actually gifted. Thank you for the roses as well. I really appreciate it. Have a good day. I'll see you again tomorrow. Bye.